All right, let me review it one more time because we're going to start deviating. And you may want to start a new drawing, right? Because by the time this class is over, your drawing's going to look horrible. So you might want to start a new one. So here we are, week 6, class 2. We're going to do trim charts a la expert Jan Roskin, the big blue book. And if you pick a center of gravity position and draw your trim chart, your CMCL curve, don't forget our CM curve is using pseudo derivatives. It is not using the actual stability derivatives. So if we're using these pseudo derivatives, the CMCL curve looks like so. It has a y-intercept for the design condition that's given by the equation, and it has a equilibrium condition, design equilibrium, and then from our CL alpha curve for an alpha design, we can get our angle of attack for design. Now I want to land, so I have to slow the airplane down. So if I'm going to slow the airplane down, which way am I going to go on this curve when I pull back on the stick? What's going to happen to these equations when I pull back on the stick? The elevated deflection is going to change. When I pull back on the stick, is this going to be positive or negative? It's going to be negative, yes? Be negative. And I will increase the moment all the way across by pulling back on the stick. So when I pull back on the stick, I will get another family of curve. And I'm going to call this delta E, I'm going to call it max, just so you realize. And then that's going to be a negative number. And that will give me another C sub L, and we'll call that the land condition, C sub L land. If I want to find the angle of attack for landing, I need to find out where this delta E max occurs on my CL alpha curve. So if I pull back, which way does the CL alpha curve go if I pull back on the stick for a negative value? Which way does my CL alpha curve go? Across the board. Will it go on this side or will it go on this side if I pull back? Right? If I pull back on the stick, the nose air curve is going to go up. So the trailing edge is going to go up. So what am I doing to lift at the tail? I am decreasing the lift at the tail, yes? This would be increasing lift at the tail. So I'm decreasing lift at the tail. Therefore, this must go backward, must look like so. Okay. Now I can, once I have this delta E max on the CL alpha curve, now I'm kind of in business because I can drop a perpendicular to where that hits over here and come across, and what's that going to be? My alpha landing. Yeah. You see how that works? My alpha landing. So I can deduce, so if I pull on the stick, I'm going to slow down the CL alpha. If I push on the stick, then I'm going to go do this kind of thing. We're going to lower the curve, and I'll have a CL here, and we'll say this is CL. I'm just going to call it min CL. That's as fast as you can go, as you want to go when you push on the stick. Similarly, that's going to result, when I push on the stick, I'm just going to draw the piece of it over here. This is going to be delta E min, right? And that's going to be a positive. Your pushing is positive, delta E max. So you'll have a minimum, a design, and a maximum stick. And you can see how messy this curve is going to get. And I assume you don't have colored pencil. So it's going to be kind of a mess. So here's the first thing we want to do. Well, the first thing we want to do is to plot this given the stability derivatives. So the first thing I would expect you to do on the next exam is, given tables from the book, given stability derivatives, I would expect you to be able to plot these on a curve, on a CMCL curve, or recognize that plot, and then recognize it. So the second question we have to ask is, can I get to this landing spot? So we have this thing called physics, and physics has a stall. So we have a stall, and we really hope that the stall line occurs right past my landing curve. So if not, that's your alpha stall, we really hope occurs farther down this axis. Well, you need 2 points. Since everything's straight lines, we're just going to pick 2 points. So if I pick the red, I picked the red, and I'll call this, I'm going to have to erase this delta E max because it's in my way. So I'm going to put delta E max on that line. That frees this up. And over here, this intersection of the stall line, I'm going to call that point A. Okay? So I'm going to come up to the red line over here, and to do that I have to extend it a bit. And I'm going to, again, you see how messy this curve's going to get. And I'm going to call this point A prime. So that's point A mapped into the CMCL curve. Now I have the blue line, and the blue line is going to intercept the stall line. So I'm intercepting the blue line over here at point B. Now you can see the problem, the same problem I had with Peter's question. I'm going to have to extend this guy, because I'm going to come up from here. I'm going to come up from here and intercept this point B. Now you're going to have to use your imagination and realize that if I didn't draw them quite so wide, this wouldn't happen. But this is going to be point B. Now if I connect point A prime and B prime, I'll have the stall line written on the CMCL curve. So now since I picked alpha stall past alpha land, you see that I have some distance here. I have some distance here that I can play with before I'm going to stall. I can land okay.